what we learned in chapter 1, solving simultaneous equations, and there's some variables k involved. And we want to know in what case, okay, there will be a unique solution, which means two lines are not parallel, they have intersections once. And they have no solutions, which means two lines are parallel lines. Okay, they have the same gradient but different y-intercept, and there will be no solution here. And infinite many solution means two lines are exactly the same line. Okay, same gradient and same y-intercept. So we solved in that approach last time. And this time we can solve it by using matrices, okay, by using matrix. But like still, I'm showing you this way, like how to use matrix to do this type of question, but I still like the previous method because I think matrix is a little bit complex. So I'm not really recommend this method. I'll still recommend the first method. But like I'm just telling you what to do here. Okay, so for this question, okay, let's have a look at this. Let's have a look at this one. What's this matrix represent for? What's this matrix represent for? What we should write is, what we can write from this is x plus ky equals to 8 and k plus 3x plus 4y equals to 2k. That's what we have according to last lesson. Okay, I said if you write the thing into the form of ax plus by, then you can set up the matrix. Okay, by writing the coefficient in 2 times 2 matrix times xy equals to the constant, but it needs to be in the correct order. Okay, it needs to be in the correct order. So I can also convert that back to the simultaneous equation in the form of ax plus by equals to c. If you can't really see this, what we can do is we can just times those two matrices. Okay, we have 2 rows and 1 column for left hand side, 2 rows and 1 column for the left hand side. So that will become like this is 2 times 2 and this is 2 times 1. We should have a 2 times 1 matrix. Okay, the middle two numbers are the same. We'll have a 2 times 1 matrix. Okay, row 1 times column 1, you have x plus ky, and row 2 times column 1 is k plus 3 times x plus 4y. Okay, and that equivalent to 8 and 2k. Okay, the top number must equals to top, the bottom must be equals to the bottom, because if two matrices are exactly the same, then the corresponding position numbers needs to be the same. Therefore, x plus ky needs to be 8 and k plus 3x plus 4y needs to be equals to 2k. Okay, so that I'll just tell you what that represent. Okay, that represent two simultaneous linear equations. And then what we'll have, okay, let's rewrite this. Let's rewrite this one. Okay, what xy equals to? Xy will equals to this inverse. Okay, in the front, you times that in the front. You have inverse of that, and 8 and 2k. Okay, times inverse at the front of both sides. So what's the inverse of that function? What's the inverse of that function? Xy should equals to 1 over 4 minus k times k plus 3. Okay, AD minus BC, right? AD is 1 times 4, BC is k times k plus 3. And inverse, okay, swap the number on the main diagonal and negative the other two. Okay, so doesn't matter what k equals to, I can always find a unique solution because you can times them together. But there's only one case you won't solve out anything. That is 4 minus k times k plus 3 is equals to 0. Only under that case, you can't find any value, okay, because it's 1 over 0, it's undefined. Your xy cannot solve out anything, except that k value or those k values. you can always find unique solution, because for example k is 1, you times the thing, put 1 in, and you can solve out 2 particular questions, answers. But if that the denominator is 0, you can't really solve out values. So that's k squared minus 3k equals to 0, k squared plus 3k minus 4 equals to 0. That will be k plus 4 times k minus 1 equals to 0. So k equals to 1, k can't be 1, just sorry about what we said before. K can't be 1, okay, you can put k equals to 2 in. But if k equals to 1, the denominator will be 0. You can't put 1 in, you can't put negative 4 in. Okay, those two numbers are the number not working. Yep.
So if 1 over 80 minus b is equal to 0, does that mean there's no inverse?
There's no inverse, and there's no unique solution. Like say, if the denominator is not 0, let's say k equals to 3, you put 3 in the all this place, and you can solve out what is x, what is y. You have 2 particular values out. Like say, same as k equals to 4 equals to 5, but only when you put k equals to 1, this doesn't work. Okay, your x and y cannot find any values. So that is the case. You will have, okay, there are 2 things. There's no unique solution, but I can have infinitely many solution or no solution. Okay, I don't know those 2 will be no solution or infinite many solution. This is the reason why I don't like this method, because I need to do a further test to see 1 is the problem with no solution, or negative 4 is the no solution one, or both of them are no solution ones. So I need to test it. I need to put that back into the system, and then I will check. Okay, I'll check. So, okay, now you know that answer for A, for the first one will be k belongs to R, except 1 and negative 4. Let's say negative 4 and 1. You know, can be anything, but can't be negative 4, can't be 1. Anything else will be correct. But it's not sufficient evidence for me to see if there's no solution or infinite many solution, which one should be that. So what I need to do is substitute back. Okay, let's say sub k equals to 1. Okay, sub k equals to 1 into which? Into the very beginning function. Okay, into the very beginning function. Okay, to this one. Okay, sub k equals to 1 into this. Let's see what I will have. I will have 1, 1, 4, 4, xy, 8, and 2. Okay, after you substitute that in, you want to see whether they are the same function or not. Okay, say, let's give you one example. If I said x plus y equals to 2, 2x plus 2y equals to 4, they are the same thing, right? They are the same thing because they have all the same proportion. Okay, x times 2, y times 2, and the answer times 2. So they are exactly the same function. So what I want to see from this is I want to see whether they are the same function or not after I substitute. Okay, times 4 times 4, but times a quarter here. Okay, they're not all in the same proportion. So k equals to 1 will be the no solution case, because you know k equals to 1 will not give you a particular answer, and also it shows that they're not the same line. What case is that? There's no solution case. Okay, there's no solution case. So if k equals to minus 4, let's sub k equals to minus 4 in. 1 minus 4 minus 1, 4. Eight minus 8. Have a look at the relationship between the first line and the bottom line. What's the relationship between that? One become negative 1 times negative 1. Negative 4 become 4 times negative 1. 8 become negative 8 you times negative 1. So the top line times negative 1 will give you the bottom line. If you can write that is x minus 4y equals to 8. minus x plus 4y equals to minus 8. They are the same line, okay? They are the same line. Because if you negative the bottom one, that will give you the top one. So minus 4 will give you infinitely many solutions. Okay, infinitely many solutions. Do you have any question about this? Okay, I'm just showing you it's not really belongs to the transformation chapter. I just like talk to this transformation. This is the only time we'll see transformation. Well, that's the only time we'll see matrix. Okay, we won't see matrix after this chapter. So I'm just trying to show you the question what we can do for the first chapter question. Okay. Let's come back to the transformation topic, okay? Come back to the transformation topic. Okay, it's a little bit hard to explain, okay? It's hard to explain because you just learn matrix. Well, I just want to tell you, matrix can represent transformations, okay? Matrix can represent transformations. Say, like a particular matrix will represent a particular transformation. So when you see the transformation, that will be the same as they give you the word description. For example, when you see the first matrix, you will know that there's a dilation from the y-axis, okay? So you need to remember the transformation matrix, okay? You need to remember the transformation matrix. So they give you word description, you should be able to write out the transformation matrix. When they give you the transformation matrix, you should give me the word description. So they are the same thing, okay? Word description and transformation matrix, they are the same thing. So let's have a look. Dilations from y-axis is changing x, right? It's changing x. So what I will have is, okay, we always have a 2 times 2 matrix. Okay, in transformation we only have 2 times 2 matrix because we only have 2-dimension graphs. Okay, only in x-axis and y-axis you only have 2 values. Then it's a 2 times 2 matrix. It never becomes a 3 times 3 matrix in high school. So dilation from y-axis is changing the x value. Okay, I'll tell you, this position left top corner is the x position, that is the y position, and those two are generally 0. Okay, are generally 0 unless some special case. So you will have 1 and n and 1, okay, on the main diagonal because it's changing x. Because it's changing x, because x dash will equals to n times x. You are putting n on the left corner. You are changing the x place. Okay, that is easy to understand. If there's a dilation from the x-axis or factor of a, therefore it's changing y. So y dash will equals to a times y. Then you need to change the y place, which is this one. Okay, the other remain the same. The other remain the same. I want to tell you, if there's no dilation, the very normal matrix will be that. Okay, there's no dilation, nothing happened, is 1, 0, 0, 1. Okay, it's not going to change x, it's not going to change y. This is an identity matrix, right? It's an identity matrix. So if it's changing y from the y-axis, it's changing x. If dilation from x-axis is changing y, it's changing that. Okay, if dilation from both axis and y-axis, you have, okay, put n here and a here. Okay, n here and a here. So you can do it together. You can do it together. Let's have a look. Transformation reflection. Okay, transformation of reflection. If it's reflect in y-axis, is changing x. X dash will become minus x. Right? Reflect in the y-axis, x dash will equals to minus x. Therefore, in the x place, you will have minus 1. In the x place, you will have minus 1. Produce a reflection in the x-axis is changing y. Okay, it's changing y. Y dash equals to minus y. So in the y place, you will have minus 1. Okay, reflect in both x and y, you have minus 1 and minus 1. Both place. Okay, both place. Okay, that's the normal reflection we learned before. Okay, only reflecting x or reflecting y. In matrix, we learn another thing, which is reflections in the line of y equals to x. Okay, if you reflect the graph by the line y equals to x, what that graph becomes to? Inverse. Okay, you become inverse. If you reflect the thing in x and y, it becomes inverse. Okay, so this will become quite interesting. So that will become 1, 1 on the other diagonal and 0, 0 on the main diagonal. Okay, it's totally changed place. Okay, that represent x, that place represent y. So that represent x, that represent y. So your x will actually become y. So you write 1 there. Okay, your x become y. So you write y here. Your y become x. You write 1 here. And the other two become 0 and 0. You don't need to understand why this matrix work like that. You just need to remember what is the matrix. Okay, what is the transformation matrix. If you reflect in the line y equals to x, you just become 0, 1, 1, 0. Okay, 0, 1, 1, 0. Okay, if you reflect in the line y equals to minus x, okay, let's see, we have a point here. Reflect in y equals to minus x, that point will become this side. Okay, you have minus 1 here, and 0, 0 on the main diagonal. Okay, 0, 0 on the main diagonal, and negative 1 over that side. Questions? Okay, so if transformation with translation, okay, if it's transformation with a translation, therefore we will have B and C. Okay, so 2 times 1 matrix. It's just B represent the horizontal movement, C represent the vertical movement. Okay, horizontal and vertical. Okay, it's quite confusing to say like that, but let's do this. I will explain that. Okay, find the image of the point and a reflection in the x-axis. Okay, it's quite easy. Actually, you can tell me the answer at once, right? Reflecting x-axis is changing the y value. It's become 2, negative 3, right? But let's do by matrix method. So what is this transformation matrix represent by reflection in the x-axis? You have 1, 0, 0, minus 1, right? When you see reflection in the x-axis, you will have 1, 0, 0, negative 1. Okay, so how do we find the image? To find the image is we put the transformation matrix in front of the original point, and I will write the original point into matrix form and in column. That's a 2 times 2 matrix, and that's a 2 times 1 matrix. Okay, why I don't put 2, 3 all in the front? Because I can't times them. Just that easy. Okay, a 2 times 1 matrix cannot times by 2 times 2 matrix. So it must be at the behind. Okay, it must be behind. So I can evaluate that by times them. Okay, row, row, column. That will equals to 1 times 2 plus 0 times 3, you still have 2 here. 0 times 2, 0 minus 3 times minus 1 times 3 is minus 3. So the coordinates will become 2 minus 3. It will become 2 minus 3. Actually the notes will stop at page 13, and it's a challenging question, okay? It's a challenging question there. You will try that question by yourself. So we have about 3 pages, 3 pages to go. Okay, let's have a look at B. A dilation of vector k from y-axis. From y-axis. So what is changing? It's changing x. It's changing x. So you have k0, 0, 1. Okay, the matrix will be k0, 0, 1. And you times that by your original points. That will give you, okay, row, column, have 2k and 3. You have 2k, 3. You have 2k, 3. Okay, that's an easy example. Okay, let's have a look at a more complex one. Consider a linear transformation T maps 1, 3 to the point -2, -3, and maps the point 2, 4 to the point -3 and -1. Okay. A transformation T, a transformation matrix T, if you transform like xy coordinates, that will be a 2 times 2 matrix. So let the transformation matrix T become A, B, C, D. You don't know what is it. Okay, you don't know what is it. What do you know is like this is transformation matrix? You may ask me, oh, I always see that 2 zeros on the diagonal. Okay, there's 2 zeros on the diagonal. Why you have all the values here? Okay, why is like that? Because like what all the matrix we see here is a single transformation. Okay, a dilation or a reflection by the line y equals x, or a moving up and down. I can times more of this matrix together to form a complex transformation. Okay, I have dilations first, and I have a reflection, and then I can have a reflection by the line y equals x, and I have another dilation. By using that, I can put all the matrix one by one, times them together, and then that will give me like a new transformation matrix, 2 times 2 transformation matrix, and that will be a more complex one. Okay, it's not necessary always have 2 zeros. If you have like more than one like transformation happens. So let's say we have A, B, C, D. We don't really know what is that, but let's say we have that. So what I know now is A, B, C, D. I'll put it over there. Times, okay, this transformation times the old point 1, 3 gives us a new point -2, -3. And I also know that the transformation matrix A, B, C, D times 2, 4 gives us -3 and -11. Yeah, that's what we know from the question. Okay, so what we can say now is expansion. Okay, expanded. Okay, we have row, column on the left hand side. So the left hand side actually gives me A plus 3B for the first row, C plus 3D on the second row gives me -2 and -3. Okay, just do expansion. Calculate them. Okay, calculate them. So A plus 3B will equals to -2. C plus 3D will equals to -3. Because if two matrices wants to be equivalent, all the corresponding position needs to have the same number. Okay, they are all 2 times 1 matrix, so A plus B must be -2. C plus 3D must be -3. Okay, similarly, what we do for the second one is the same. Okay, we will have 2a plus 4b and 2c plus 4d equals to minus 3 and minus 11. So 2a plus 4b equals to minus 3, 2c plus 4d equals to minus 11. Yep. Oh, you just calculations of the matrix. So how do you do calculation of matrix? You times one tree matrix with another matrix. So that's two matrix. And you want to equivalent to the third one. And I can have four linear equations here. We have four linear equations here. And I can solve those four linear equations. Okay, you have A, B, and AB. So let's say this one is equation number 1. That's equation number 2. We have equation number 3 and equation number 4. Okay, so what I want to do is I will times equation 1 by 2. That gives me 2a plus 6b equals to minus 4. Let's say that's equation number 5. And let's use equation number 5 to subtract equation number 2. Okay, equation number 5 is that one. Equation number 2 is that one. 2a subtract 2a, just gone. 6b minus 4b, we're left with 2b. Minus 4 minus negative 3. 2b will give me negative 1. b will be negative a half. The b will be negative a half. Therefore, a will be minus 2 minus 3 times b. 3 times negative a half. Okay, use the from the first equation, we know that a will be minus 2, subtract 3 times b is subtract 3 times negative 2. So a will be negative 4 over 2 plus 3 over 2. A will be minus a half. Okay, similarly, you want to solve for C and D. Let's times equation 3 by 2. That is 2c plus 6d equals to negative 6. Let's say that's equation number 6. Equation number 6 minus equation number 4 will give me 2c and 2c just gone, and 6d minus 4d is 2d. 2d equals to minus 6 minus negative 11. So 2d equals to positive 5. d will be 5 over 2. And from equation number 3, c will be minus 3 minus 3d. 3 times 5 over 2. c will be minus 6 over 2 minus 15 over 2. C will be minus 21 over 2. Okay, it's just purely problems or simultaneous linear equation. Okay, solving. Just solving for C and D. Just solving for C and D. Okay, t equals to minus a half minus a half minus 21 over 2 and 5 over 2. Okay, that is the transformation matrix. Okay, that is the transformation matrix. Okay, any question about this? This is like one type of question. You can see on your textbook, okay, you have a couple of questions like that. So from one point to another point, and then from one point to another point, give you two set values, okay? Two like begin and like before and after values, and ask you what is the transformation matrix you have. Okay, what is the transformation matrix you have? Okay, let's have a look at next one. Yeah. Oh, you find the image of that. I forgot that totally. Have no place now. Okay. Okay, find the image of -1, 1. Well, okay, I'll write on the bottom. Okay. Find the image. Well, okay, find the image of -1, 1. So I will times -1, 1 to the transformation matrix. Okay, times this to the transformation matrix. And then what I will have is, I can take the -1/2 out. That become 1, 1, 21, and -5. And then times that by -1 and 1. Yeah, I want to take a -1/2 out. It's not necessary to take it out. I just think it's easy to calculate. And I will time those two matrices together. Well, that's a half times 1 times -1 is -1, -1 plus 1 is 0. 21 times -1 is -21. -5 times 1 is -5. -21 plus -5 is -26. And you times the -1/2 in 0 and 13. So the image will be 0 and 13. Put it to top. Okay. Just let's keep going. Just want to finish all this concept today, and tomorrow you can have a revision lesson, and you have any questions you can ask me on the lesson. Okay, it's better than directly just have the test. So tomorrow you can work on the class. Example 3. Find the image of the point under a reflection in the x-axis and followed by a dilation factor k from the y-axis. Okay. The point I want to make here, like this is an easy question. When you see the question, you will think about it's quite easy questions. But I want to say the order you put the transformation matrix will be to the front. It's not to the back. So what means by that? You have a point 2, -3. You under a reflection in the line x-axis. So if you have x-axis, it's changing the y value. Okay, it's changing the y value. So you have 1, 0, 0, minus 1. Okay, and the reflection in the x-axis is changing the y value. So you have 1, 0, 0, negative 1. And followed by a dilation of vector k from the y-x-axis. So is changing x is k, 0, 0, 1. But this k, 0, 0, 1 must be in the front, not at the back. Okay, for this question, if you swap the order of those two, doesn't really matter. Okay, if you swap the order of these two, doesn't matter. But for some particular questions, especially for the ones if you have a reflection in the line y equals to x, that does matter. Okay, so the order is important. But like for this case, it doesn't really have got any influence. But for some other, for example, reflect in line y equals to x first and then dilate by a factor of 3, that will be different as like you dilate by a factor of 3 and then reflect in line y equals to x. Therefore, the order is important. So you need to times that all in the front. Okay, which one happens first will be really close to the original point. And you times next one to the front of the first one. Okay, if you have a third one, you times it to the front of the third one. Okay, the second one. So basically now you want to calculate this. You want to calculate on that. So you will times the matrix together. Okay, row times row, column times column. That equals 2. Okay, it will be a 2 times 2 matrix still. So for the first one, you have k times 1 is k, 0 times 0 is 0, so we have k here. Row 1, column 2, k times 0 is 0, 0 times minus 1 is still 0, so you have 0 here. 0 times 1 is 0, 1 times 0 is 0, you still have 0 here. 0 times 0 plus 1 times minus 1, which is minus 1 here. And you have this times that. Okay, this one. Oh, this matrix. Okay, this matrix here is the combination of the dilation and reflection. Okay, it's a combination matrix of dilation and reflection. So you use that to times this by 2, negative 3. So it's still row times column. What I will have is 2 times 0 2 plus 0 times minus 3. You have 2, and you have 0. Oh, which one's k? Oh, yeah. Yes, that's k. So it's 2k. And then you have minus 1 times minus 3. You have 3. Okay, so 2 minus 3 will be changed to 2k. 3. But like the point I want to make here is the order of the matrix. Okay, how you write your matrix? Your matrix must be put in the front. Okay, the new one, like the first one needs to be close to the original points, and the next one is in front of the first one. The third one will be in front of the second one. So that's the important thing about this question. Okay, example 4. Express the composition of transformation dilation of vector k from the y-axis. Okay, express the composition of matrix transformation. Okay, first one is dilation of vector k from y-axis. That's the first one. Followed by a translation defined by that. Okay, now we have translations. Mapping a point xy to a point x dash y dash as a matrix equation. Hence, find x and y in terms of x dash and y dash. Okay, so what happens in this question basically? 2 transformation happens. One dilation and one movement, like horizontal and vertical movement. Okay, they asked us to set up a transformation matrix. Okay, the notation of transformation is very important. The notation of transformation is very important. So what is the, like, I'll just show you the notation, okay? So the notation, what you have is T bracket xy bracket. What that means, okay, to not really hard to copy what that means. That means the original point xy under the transformation or undergoes the transformation t. That will equivalent to say that is the new x and new y point. Okay, when we say txy, it's the same as we say x dash and y dash. Okay, that's a particular notation. Okay, all the transformation question will use this notation. It means the original xy points undergoes the transformation t, which means you will have the x dash and y dash point. So what happened in this question is txy equals to, or let's directly say x dash y dash. Let's directly say x dash y dash. Okay. New point equals to what? New point equals to the dilation of k from the y-x-axis. So k0, 0, 1 times the original points named as xy, and plus what? Plus the translation matrix AB. Okay, the translation matrix AB. That's what we can have. Okay, that is what we can have. Okay, now I finish. Okay, this is the setup mapping xy x dash y dash as a matrix equation. That is a matrix equation. Okay, that is a matrix equation. You just want to say the new xy equals to what? Okay, the new xy equals to the transformation matrix times xy plus the translation matrix. Hence, find xy in terms of x dash y dash. Okay, be careful here. I have two methods to show you. One is the book method, and it's the one I really think is quite silly. Okay, second is a method really like normal people will go through, okay? Like, I don't know why the book method is like that, but it's really quite annoying. I don't know why they're using that one. I think maybe they want you to use inverse matrix, but I don't think like it's really important to do that. So let's do a normal method first, okay? I will put like a normal method. So what that method is, that is you just calculate that. Okay, follow this and calculate that. So you will times those two matrices together. Okay, this will gives you kx, kx and y plus AB. So x dash y dash will equals to kx plus a and y plus b. Just do normal calculation, okay? And then we'll say x dash will equals to kx plus a and y dash will equals to y plus b. Which variable they want you to make it to the subject? X and y. So we have x dash y dash at the moment, so it doesn't matter. Let's put it as x equals to x dash minus a divided by k. Y equals to y dash minus b. Done. Okay, done. Do you think this method is easy? Okay, we just do calculations, we expand it, and then we set up two equations and we're trying to make x, y to be the subject. Okay, really easy. Let's see the book method. Okay, what the book trying to do is they want to use matrix to solve for xy. They want to use matrix to solve x and y. So how we can solve x and y? First, we have this one equals to x dash minus a, y dash minus b. Correct? We have that. And then we will have xy equals to the inverse of this function times x dash minus a, y dash minus b. Okay, we have that. I'm trying to find the inverse. And then we want to find what's the inverse of that? The inverse of that is AD minus BC, which is 1 over K. Okay, and I will swap the order of that. You have 1 here, 0 here, 0 here, K here. Negative 0 is still 0. Okay, you change the number on the main diagonal, you negative the other two. And you have x dash minus a, y dash minus b. Okay. Next thing is I want to times those two matrices together. Okay, x minus a is one number. Okay, it's row 2 column 1. It's just one column. You will have xy equals to 1 over k. Okay, 1 times x dash minus a, x dash minus a, 0 plus that will be 0. Row 2 times 0 times that is 0 plus k times y dash minus b. And then xy equals to x dash over a divided by k, and that is just y dash over b. So we have x equals to x dash minus a over k and y equals to y dash minus b. So we still have the same answer, but just have a look at how many extra lines it needed. Okay, so you find inverse, yes, like I find inverse, and I still need to times two matrices together. What's the point? Okay, like I find the inverse and I times two matrices together. Why we just directly times two matrices together in the first one and rearrange it by like normal method? Okay, so it doesn't really necessary to rearrange it in the matrix. Okay, we can expand the matrix first and then rearrange it. Okay, well, but remember, you need to know how to do both methods. Okay, I would recommend the first one, but you need to know both of them because some question will leading you through this method. Okay, they will just force you to use this method. Okay, they want to test your knowledge on inverse matrix, so you must do this method. So it's just leading you through. There's no choice. So you need to understand this method as well. But if there's like no requirement, just go for that. Okay, just go for that. Okay. Okay, I'll just have 2 short questions. I know it's quite long already, but I really want to finish those 2, and tomorrow we can just have pure revision class. Example 1, a transformation is defined by a matrix. Okay, this matrix we'll call matrix T. Find the equation of the image. Okay, now it's back to type 1 or type 2 question. Okay, give you a transformation matrix and ask you the image function of this equation. Okay, ask you the image of this equation. I want to know the image of that. So this is the xy equation. Okay, I want to know x dash y dash. I want to find x dash y dash. Okay, remember when you see matrix questions, you always start with T bracket xy equals to the transformation matrix times the original value xy. Okay, it's always the new one equals to the T matrix times the old coordinates. It's always in this order. If you have plus something, minus something, just plus minus at the back. Just plus minus at the back. And you have row, and column. And this one, okay, this one represents x dash y dash as I explained. So you can change it to x dash y dash in the next step. And that equivalent to x plus 0 and 0 plus 2y. So I have x and 2y. So what I can have is x dash equals to x, y dash equals to 2y. Okay, x equals to x dash and y dash equals to 2y. Okay, for this question, do we need x to be the subject or do we need to make y dash x dash to be the subject? I want to find the new equation. I have the old one. xy or x dash y dash? To be the subject. I have x dash y dash to be the subject now. Do I need to change it to substitute or can I directly substitute? What I have here, that's y, that's x. That looks different as x dash y dash, okay? So you need x, y to be the subject. So x will equals to x dash, y will equals to a half y. So you need to substitute x in terms of x dash, substitute y in terms of y dash. So it's back to the original type. Okay, after the transformation, I calculated, I expanded back to the very original question. So my y will become a half y dash. And x just changed to x dash. So y equals to 2x squared plus 4x plus 6. Example 2. A transformation is described by the equation t bracket x plus b bracket equals x dash, where t equals to that, b equals to that. Okay, x, what is x? X is just xy. What's x dash? X dash is x dash y dash. Okay. So find the image of the straight line with the equation y equals to 2x plus 5. That's the original equation. So let's just expand that. Okay, so what I can see from here, t, what is t? T is 0, negative 3, 2, 0. Bracket x. X is xy. Plus b. What is b? B is 1, 2. Finish the bracket equals to x dash. What is x dash? X dash is x dash y dash. Just write what just tells you. Okay, it tells you that, you just write that. So I will have x plus 1, y plus 2 equals to x dash, y dash. So you have the bracket here. You need to plus that, minus that first. we will have the row for the first one and the column for the second one. So what you have is minus 3y plus 2, 2 bracket x plus 1 equals to x dash y dash. Minus 3y plus 2 equals to x dash. 2 bracket x plus 1 equals to y dash. Okay, can you see this question? On the main diagonal, you have 0, 0. On the main diagonal, you have 0, 0, which means there must involve reflection in the line y equals to x. Okay, must have that reflection. But there's also other dilations, reflections. I don't know the order of them, but it's okay. So I can just have that first. Okay, I can find x dash y dash in terms of x and y. But I have original equation. I can't have x dash y dash because I want to do substitutions. So I need x and y to be the subject. So y plus 2 equals to minus a third x dash. Y will equals to minus a third x dash minus 2. X plus 1 equals to a half y dash. X will equals to a half y dash, subtract by 1. And then I can do substitutions. So y become negative a third x dash minus 2 equals to 2x. So what is x? X is a half y dash minus 1. Finish the bracket, plus 5. Minus a third x dash minus 2 equals to y dash minus 2 plus 5. Negative a third x dash minus 2 equals to y dash plus 3. Y dash equals to minus a third x dash minus 5. Okay, rearrange it. So y equals to minus a third x minus 5 is the image equation.